All right, let's talk about one of the weirdest, most frustrating things in AI right now: hallucinations. You've been there, right? You ask this super smart AI a simple question, and it just makes something up, but with total confidence. It's baffling. But what if I told you that's not a bug? A brand new paper is making this wild argument that AI hallucinations are actually a feature of the tests we give them.
I mean, this is the big question, isn't it? How can these incredibly powerful models be so confidently wrong? We've all seen it. You ask for a simple fact, and you get back an answer that sounds totally plausible, delivered with absolute authority, but it's pure fiction. It's more than just annoying. It really gets in the way of us being able to trust these systems. So, what is actually going on under the hood?
And this is just a perfect, almost funny example from the paper's lead author. He asked an AI for his own birthday, and look at the answers it spit out: July 3rd, June 15th, January 1st. The paper just dryly points out that his actual birthday is in the autumn. See? It's not just a little bit off. It's confidently, randomly, and completely wrong. This is the problem in a nutshell. So this brings us to the core argument of the paper, and it kind of flips the whole problem on its head. What if we're looking at this all wrong? What if the AI isn't a broken truth machine? What if it's actually a perfectly built, confident guessing machine? The idea is that these hallucinations happen because the AI's training rewards it for being a great test taker, not for being truthful. To make this super clear, the paper gives us this fantastic analogy that we're going to run with. Just think of an AI like a student. Its entire life is a two-stage education. First, it goes to this massive primary school to learn the basics, and then it's immediately thrown into a series of high-stakes final exams. So let's start with Act 1, where the error is born. We're diving into the AI's primary school days. This is what researchers call pre-training. And as you're about to see, this is where the very first seeds of hallucination get planted. So during pre-training, the model basically reads the entire internet. But it's not memorizing facts like you or I would. Instead, it's just learning the statistical patterns of language. It's figuring out what words and sentences just sound right next to each other. It's kind of like a toddler learning the rhythm of speech long before they know what a historical fact even is. This diagram from the paper really breaks it down. Learning is basically a giant game of flashcards. The AI sees a statement and has to decide, is this valid or is it an error? So on the left, you've got the good stuff, the valid examples, greetings, counting, things that follow clear patterns. On the right, the errors. Now, some errors, like spelling mistakes, are also easy to spot because they break a pattern. But look down there, birthdays. What's the pattern for a person's birthday? There isn't one. It's just a random, arbitrary piece of information. And that, right there, is where the trouble starts. And here's the kicker. The paper shows that for an AI, it is statistically way easier to recognize if a statement is correct than it is to generate a correct statement from scratch. Just think about it. Even with perfect textbooks, the odds are just stacked against it. It's way more likely to spit out something that sounds plausible but is wrong than to perfectly remember some obscure fact it only saw once in a trillion words. The paper even puts some hard numbers on this. They talk about something called the singleton rate. That's the percentage of facts that pop up only a single time in all its training data. And a fact that's only mentioned once, that's a super weak signal for the model. So, as you can see here, they found a direct link. If 20% of birthday facts are singletons, well, then you should expect the model to just make up at least 20% of them. It's not a glitch, it's just math.
Okay, so that was primary school. Now for Act 2, the guessing game. This is the high-stakes exam part of its life, also known as post-training. And this is where those little statistical errors from primary school don't just stick around. They get supercharged into confident, bold-faced lies.
Right. So after learning the basics, our AI student is fine-tuned with one goal, and one goal only: get the highest possible score on its final exams. In the AI world, these exams are called benchmarks, and acing them is everything. The goal isn't to be truthful anymore, it's to win. And this is basically the AI's report card. It shows the rules of the game for its biggest exams. Take a look at these major benchmarks: MMLU, math, you name it. The paper points out that they all have the same fatal flaw. Every single one rewards guessing, and not a single one gives you points for just saying, I don't know. And that's the score. That's what our AI student gets for being honest. A big, fat 0. Now, if you're taking a multiple choice test and a random guess gives you, say, a 25% chance of getting it right, why would you ever choose the option that guarantees you 0 points? You wouldn't. The system is telling you loud and clear, always, always guess. Okay, these two charts might be the most powerful visual in the whole paper. They're called calibration curves, and they show us exactly how this test-taking pressure changes the AI. See that dotted line? That's the sweet spot, where confidence perfectly matches accuracy. On the left, that's our AI back in primary school. The blue bars are pretty close to the line, right? Its confidence is, well, it's pretty honest. It knows what it knows. But now look at the chart on the right. This is our AI after it's been prepped for the big exams. Whoa, the bars have shot through the roof. Its confidence is now sky high, even when its actual chance of being right is still pretty low. It has literally been trained to become an overconfident bluffer because that's what gets the A+.
So, if the tests are the real problem, what do we do? Well, the paper solution is both simple and pretty radical. Stop trying to fix the student. Instead, let's fix the test. The authors argue that the entire AI field has created what they call an epidemic of penalizing uncertainty. The whole incentive structure is just wrong. We're not dealing with a few faulty AIs. We're dealing with a grading system that is systematically designed to create these confident guessers. And the solution they propose is actually super straightforward. Step 1, the problem, this all-or-nothing grading system where you either get a point or you get nothing. It always rewards a guess. Step 2, the solution, start penalizing wrong answers, just like the SATs used to do. And step 3, the result, all of a sudden the AI has a real incentive to say, I don't know, because a wrong guess will now cost it more than just being honest. And here's what that actually looks like. You just change the rules of the game, and you tell the AI up front. Check out this example from the paper. You tell it, a correct answer gets you 1 point, I don't know gets you 0, but a mistake? That's -9 points. Now the AI has to be more than 90% sure before it even risks an answer. Bluffing just became a really bad strategy. So, let's zoom out and put a bow on this. What does this way of thinking about AI hallucinations really mean for all of us? Okay, so the big takeaways. First, hallucinations are not some ghost in the machine. They are a predictable outcome of how we teach these things. The primary school phase creates the potential for errors on rare facts. And then the final exams train the AI to guess confidently instead of admitting when it's not sure. And maybe the most important takeaway is that the best fix isn't some deep, complicated surgery on the AI's brain. It's just to change the test. So from now on, when you see an AI just confidently invent something out of thin air, try to remember what you're actually witnessing. It's not a broken machine. No, what you're seeing is a star student, one that has perfectly optimized its behavior to get the highest score possible on the tests we designed, playing the game by the exact rules that we gave it. And that really leaves us with one final, pretty heavy question. This whole line of thinking forces us to ask what we actually want from our AI. If our goal is to build systems we can genuinely trust, then isn't it time we stopped giving the best grades to the most confident bluffers in the class?